All right, guys. Like I said, this second part of the class is for us to begin to solve questions. And you can see I have WAEC past question with me. This WAEC past question, I'll be taking the questions from there, basically. So we need to begin to know how to use these formulas. So the first question is going to be the first question. I'm going to look at the first question in this mole calculation. So I'm going to start applying the formulas. The first question says that how many moles are there in 6 grams of magnesium? How many moles are there in 6 grams of magnesium? You are given that magnesium is 24. That is, the molar mass of magnesium is 24. Very simple. What do you do with this information? Read the question very well. The question very well. The question says, how many moles are there in 6 grams? So that means mass in the question is 6 grams. What are you looking for? So that's the problem with most chemistry students. They cannot read their question very well. The fear of question is the beginning of failure. You must learn how to read your questions very well, and you must not shy away from your question, because sometimes before ever you start reading the question, you are already panicking. Like, what kind of question is this? Read it slowly and gently. What's the number of moles? What is the number of moles, or how many moles are there in 6 grams of magnesium? Very simple. So what do? Mass is 6 grams, and then you are given relative atomic mass of magnesium is 24. So it's very simple. So how do we solve this question? You just say that number of moles, equation 1 says number of moles is mass over molar mass. That's your equation 1. So what is that giving you? So mass is 6, and the molar mass in the question given is 24. Or that should give us something like 0.25, okay? 0.25 mole. The answer is 0.25 mole. Very simple. Okay, next question. Calculate the number of moles in 20 grams of calcium trioxocarbonate 4. Calculate the number of moles in 20 grams of calcium trioxocarbonate 4. Calculate the number of moles in 20 grams of calcium trioxocarbonate 4. Calculate the number of moles in 20 grams of calcium trioxocarbonate 4. So you are given calcium trioxocarbonate 4. Please don't worry, we are going to take this how to write chemical formula, balanced chemical equation. We are going to take that topic separately. So calcium will be given as 40 in the question. Then carbon will be given as 12 in the question. Then you have oxygen given as 16 in the question. Very simple. So you have calcium is 40, carbon is 12, oxygen is 16. Okay, so how do you do that? Read the question very well. Question says that calculate the number of moles. So for solution, for solution, number of moles, I don't have it. The question is saying that we have mass. Okay, mass is 20 grams. Very simple. Now I can calculate the molar mass. So in doing that, how do I get the molar mass of this compound? Very simple. Molar mass of calcium trioxocarbonate 4 will give us 40 plus, what is carbon? Carbon is 12. Plus, then That's 16 times 3. Okay, so you have this, everything should give us like 100 gram per mole. Please confirm. Give us like 100 grams per mole. So what do we do with this information? It's very simple. We have the molar mass, we have the mass, and we are just looking for number of moles. So that's going to give us number of moles will be mass over molar mass. No story. Oh yeah, put your parameters in. So mass is 20, okay? Molar mass is 100. Please figure me. That is going to give us something like 0.2 mole. 0.2 moles. So what we are doing is that we are taking questions and we are applying those questions, those formulas to the question. These things are very simple. You just need to start reading your question carefully and slowly. So we have solved 2 questions already. So let's move on and solve the 3rd question. So I will begin to look at how you can get through with all of these things. They are very simple. Now, remember I told you that we're taking your questions from standard questions like WAEC pass questions, JAMB pass questions, and all the rest. Now, the next question is saying, how many, next question is saying, saying determine the determine the amount of 5.6 cm cube of a gas at STP. Determine the amount of 5.6 cm cube of a gas at STP. Determine the amount. Question says determine the amount of 5.6 cm cube of a gas at STP. Remember when I was teaching you the formulas, I told you that whenever you hear the word STP, your mind should quickly rush to those formulas and the parameters. I told you that 1 mole of a gas is equal to 22.4 dm cube or 22400 cm cube. That's very simple. Determine the amount. Now, when you hear amount is also known as mole. So read the question carefully. Determine the amount. So amount means number of moles. That's what it's saying. Amount means mole. So that means number of moles, I don't have you. Here we go. Determine the amount of 5.6 cm cube of a gas at STP. It means that the volume given in the question. How do I know it is volume? Because of the unit. You identify a parameter in a question with a unit. So if I'm talking about mass, what will be the unit of the mass? It's gram or kilogram. So you determine the value of a parameter or what the parameter is when you are using the unit. So volume in this question is 5.6 cm cube. Now here is a huge leaping or whatever you want to do with this now. You want to look at 5.6 cm cube. Which of the parameters or which of the standard will I use? Now, 5.6 cm cube. Cm cube, we are going to use 22400 instead of 2.4 dm cube. So here we go. We have number of moles will be volume. Our volume in the question now is 5.6. That's the volume in the question. Our volume in the question is 5.6 cm cube. So that means our volume is in cm cube. I'm going to divide it by 22400. Why am I using 22400? Because the volume given in the question is in cm cube. So number of moles will be 5.6 over 22400 cm cube. And if you do the math should give you 0.00025. That's 0.00025 mole. That is the answer. Remember that the bait in the question is the volume. If the volume was in dm cube, I will not use 22400. I will use 22.4 dm cube. That's next. Let's now go to the next question. All right, so we have solved question 1, 2, 3. Let's go to question 4. Question number 4. I'm applying those formulas I gave you. Now, I have another question in this place. And the question says, it says, what is the amount of solute contained? What's the amount of solute contained in 200 cm cube? What is the amount of solute contained in 200 cm cube of 0.05 mole per dm cube of the solution? I'll read that again. What is the amount? So let's look at that straight away. Amount means number of moles. So amount, and I don't know. What is the amount of solute contained in 200 cm cube? So that means the volume is 200 cm cube. Continue. Of 0.05 mole per dm cube. That means concentration 0.05 mole per dm cube. That's concentration. Now, if that is concentration, they said find the number of moles. Oh, this is very simple. That's going to give us number of moles is concentration times volume. Now, my volume is in cm cube from the question. How do I know? 200 cm cube. Then you're going to divide it by 1,000. Very simple. So what do? Concentration is 0.05 times, what's the volume? The volume is 200 divided by 1,000. And that should give us 0.01. 0.01 mole is the answer. Okay, so let's fire on. We have some things to do here. Okay, so fine. That is that. Question number 5. How many moles are there in 0.2 mole per dm cube of 2 dm cube solution? How many moles are there? How many moles are there? How many moles are there in 0.2 mole per dm cube of 2 dm cube solution? Now, different from the first question initially I solved. This one, the volume is given in dm cube. So let's read the question carefully and follow it. How many moles? So solution, how many moles? Number of moles is unknown. How many moles? And then are there in concentration is 0.2 mole per dm cube. That's what you have. Then of 2 dm cube solution. So volume is 2 dm cube solution. This is quite different. Why? Because volume is now in dm cube. The previous one I solved was in cm cube. So how do you do that? Number of moles is concentration times volume. There is no need to divide by 1,000. Why? Because the volume given is in dm cube. So here we go. Concentration 0.2 times volume. Volume is 2. So that's 0.4 mole. 0.4 mole. Very, very simple. Now, let's look at this question. And the next question, let's fire on. In the next question, we are going to look at how these are very simple ones. We are going to look at very technical ones. The next question says, calculate the number of atoms. Calculate the number of atoms in 6 grams of magnesium. Calculate the number of atoms. And I was telling you this, I told you something about particles. And I said, particles refer to one, atom. Particles refers to molecule. And particles refer to ion. I said that. So particles, atom, molecule, and ion. That is particle. Atom, molecule, and ion. And I said the question now says calculate the number of All All right. So the question says, for particles, pay attention. Particles include atom, molecule, and ion. So here we go. Calculate the number of atoms in 6 grams of magnesium. Calculate the number of atoms in 6 grams of magnesium. Remember Avogadro's constant. Remember Avogadro's constant. Avogadro's constant says that 1 mole of a substance is equal to 6.02 times 10 raised to the power of 23. That is Avogadro's constant. Here we go. They said calculate the number of atoms. So that means I am looking for number of atoms. So solution, I am looking for number of atoms. Very simple. Here we go. So if I'm looking for number of atoms, then they gave us mass. They say the mass, I'm looking for this. They say the mass is 6 grams. And the element given in the question is magnesium. I know that magnesium atomic mass is 24. Very simple. So what do? We just say mass over molar mass is equal to number of particles. Number of particles divided by Avogadro's constant. Number of particles divided by Avogadro's constant. Very simple. So we start imputing the formulas. Here we go. Mass is already 6. Molar mass is 24. You are looking for number of particles. Now, in this question, what is the number of particles in the question? They say you should find number of atoms. So replace the particle with number of what? Atoms. So this one will become number of atoms. Number of atoms. Then you have 6.02 is power 23. What do? Then cross multiply. So number of atoms equals to 6 times 6.02 times 10 raised to the power of 23 divided by 24. And if you do that math, that should give you something like 1.505 times 10 raised to the power of 23 atoms. That should give you 1.505. That is 1.505 times 10 raised to the power of 23 atoms. Very simple. 1.505 times 10 raised to the power of 23 atoms. Very, very simple. Okay, so you can see the way I solved the question. Anytime you hear particles, they refer to what? Atoms, molecule, and ions. Now, okay, so let's go to the next question. Very simple. Let's move to the next question. And the next question is so simple because everything I've taught you in the previous class, we are just applying the formulas. That's what we are doing. We are applying the formulas. And then here we go. What is the molar mass of 1.1 gram of a gas that occupies a volume? Question says, what is the molar mass of 1.1 gram of a gas that occupies a volume of 560 cm cube at STP? That word at STP must be included. And that is a clue. Whenever you hear the word STP, it's a clue. The clue is, okay, I must bring in that 1 mole of a gas at STP is equal to 22.4 dm cube or 22400 cm cube, depending on the volume you have in the question. So the question says, what is the molar mass of 1.1 gram of gas that occupies a volume of 560 cm cube at STP? So let's go. Now, what do you do with this question? Very simple. Start breaking them down. as a science student, when you are given a question, the first thing to do is to break them down. Break your question down, because to eat an elephant, you must eat it in bits, or else you cannot finish it. I doubt if anybody can finish an elephant alone. Okay, so but this looks like an elephant. So you have to break it down. So here we go. What is the molar mass? So molar mass is unknown. Molar mass unknown of a 1.1 gram. So you have mass. So molar mass unknown, but I have mass. Mass is 1.1 gram. 1.1 gram of the gas occupies, what is the volume? The volume it occupies is 560 cm cube. That's all. I've broken them down. So what do? I want to now calculate. Very simple. So what do? I'll say, okay, mass over molar mass will be equal to volume. Now, this time around, my volume is given in cm cube. So divided by 22400. Remember that you are bringing this value only when you are talking of gas, and the gas is at STP. So let's go. Do I have mass? Yes, 1.1. Do I have molar mass? No, I'm looking for you. Equal to, do I have volume? Yes. Volume is 560. Then divided by 22400. So can you cross multiply? Why not? I can do that. So here we go. That will be 1.1 times 22400 divided by 560. Now, if you do that math, that should give us something like 44.0 gram per mole. That's 44.0 gram per mole. That's 44.0 gram per mole. Okay, so let's move on. Let's squeeze in one more question. That's will be question 8 now. Let's squeeze in one more question. Let's squeeze in one more question. Okay, one more question. Let's squeeze in. The question says, what volume of solution would be required? What volume of solution would be required? What volume of solution will be required to prepare 5.3 grams of 0.015 mole per dm cube sodium trioxocarbonate 4? What volume of solution would be required to prepare 5.3 gram of 0.015 mole per dm cube sodium trioxocarbonate 4? Okay, you are given that carbon is 12. You are given that sodium is 23. You are given that oxygen is 16. That's what you are given. Now, let's break it down. That's what you are supposed to do. What volume? Okay, volume is unknown. I'm looking for you. Would be required to prepare 5.3. That means the mass is 5.3 grams. No problem. Of 0.015 mole per dm cube. That means concentration is 0.015 mole per dm cube. That's the concentration. Okay, that's all. So the next thing I'm going to do is find the molar mass. What's the molar mass of sodium trioxocarbonate 4? Molar mass becomes, what is this one? 23 times 2. Okay? 12 plus 16 times 3. If you add up everything, it should give you 106 gram per mole. Very simple. 106 gram per mole. So what do you do with this information? Go to your formula. That's going to give you mass over molar mass is equal to concentration times volume. Okay, it was not specified whether to find the volume is in dm cube or cm cube. Let's just go on with the volume in, let's look at the volume in cm cube. Okay, then divide it by 1000. Okay, what do we do with this information? Now, Please put in your parameters. Mass is 5.3. Molar mass is 106. Concentration 0.015 times what is the volume I'm looking for you over 1000. The volume you get here must be in cm cube, so cross multiply. So volume becomes 5.3 times 1000, okay, divided by 106 multiplied by 0.015. So that should give us 3.333. That should give us 3.333. That's 3 points. That should give us 3. Don't know. That's 3. Not points. 333. Something like this. In cm cube. That's that. Then if you want to take it to dm cube, you just divide it by 1000. And when by 1000, you will get the volume in dm cube. All right. That's that. Okay, so I've tried to solve like 6 or 7 questions or 8 thereabout using the formula that I gave you in the first question. But this is not all. The secret in getting more concept, the secret is that you are going to keep practicing. Get WAEC pass question, get JAMB pass question, and continue to practice. That's the secret. So there's no any kind of gimmicks or there's no magic to this. Now, if you want to be good, you need to practice. A lot of science students, they want to have good results, but they don't want to practice. So in Dockyelele Academy, what we do is we do focus and strategic studies. Because we know when a student can focus and can be given a strategy to work or solve questions or study, that student will pass. There is nobody that has 2 brains. Nobody came with 2 brains. Anybody you see on earth must have acquired what the person got on earth. It depends on how you use your time. As a science student, use your time to practice. What you don't practice regularly, you don't expect it to stick to your brain. So we encourage our students to always practice these questions. You have been given the formula. All you do is solve more. And any more you cannot solve, you can drop it and say, oh, you cannot solve this. Maybe in the comment section, or drop it. Find a way to drop it. We'll solve it for you. So I have always told students, what is worth doing is worth doing well. You cannot sow pawpaw and expect to reap apple. It's not possible. It's garbage in, garbage out. What you sow is what you are going to reap. If you sow laziness, you will reap laziness. If you sow hard work, you are meant to reap success. That's the way it works. Science is principle. It's not that you want to do magic. There's no magic here. The only magic you can do is to read your book. Study. Study very hard. The moment you have the principle, the moment you have the formulas, get to work. Start practicing now. And I'm calling those people that want to write JAMB. You want to write JAMB next year, you are expecting to start preparing next year. It's not done that way. Proper preparation will prevent poor performance. Let it stick. Proper preparation prevents poor performance. Start studying now. For those who have ears, let them hear. Like I say, ayinite, ayinipada, ohun tó jọ la fi ń wé hun, and something wey resemble hun is used for hun. Practice. Practice.